Scientists drilled into fresh Antarctic snow that fell within the last couple of decades, and pulled radioactive iron out of it. That's the problem. This particular iron can't form on Earth. No natural process on this planet makes it. It comes from one place, the core of a massive star. In the instant, it tears itself apart. So that snow carries the ash of dead stars, and it's still falling, right now, onto the poles. Which leaves two possibilities. Either a star exploded close to us recently, and it didn't, we'd have seen it, or we are sitting inside the wreckage of ones that died a very long time ago. The answer turned out to be the second. And buried inside it is a quieter question scientists are still arguing about: whether any of that wreckage ever touched the planet we're standing on. This is First Signal. Today, let's follow one radioactive atom from a snowflake in Antarctica out to the enormous invisible structure our whole solar system is drifting through, without most people ever knowing it's there. The isotope is iron-60, and one fact about it is all you need. It's radioactive, and it decays fast on a cosmic scale. Half of any batch is gone every 2.6 million years. Sit with what that implies. If this iron had been here when Earth formed 4.5 billion years ago, it would have vanished hundreds of times over. So any iron-60 we find today can't be a leftover. It has to be fresh. It has to have arrived recently from a star that exploded, because that's the only place it's made. Finding it near Earth is, quite literally, holding a piece of a dead star in your hand. In 2019, a team at the Technical University of Munich, led by Dominic Koll, did something clever. Instead of digging through ancient rock, they looked at recent Antarctic snow, less than 20 years old, pristine, modern, and had iron-60 in it. Feel the weight of that. Fresh snow means recent delivery, but there's been no nearby supernova in all of recorded human history. Nothing has blown up close enough, recently enough, to be dusting our poles last Tuesday. So where was it coming from? For a few years, that question just sat there. Then, in 2026, a new study cracked it. The team went deeper into the ice, reading layers from 40,000 to 80,000 years ago, and lined them up against iron-60 buried in deep-sea crusts. What they found wasn't a single spike, the mark you'd expect from one explosion that dumped its debris and faded. It was a continuous signal, a steady rain of iron-60, going on and on. And Earth is collecting more of it now than it did in the older, deeper layers. A one-time blast doesn't behave like that. Something continuous does. And only one thing fits. We are not catching the debris of a single explosion. We are flying through a cloud of it. Our solar system is passing through a region called the Local Interstellar Cloud, sometimes the local fluff. A wisp of gas and dust, barely denser than the vacuum around it, seeded with iron from ancient supernovae. As the sun ploughs through, that material drifts down, settles through the atmosphere, and locks into Antarctic snow, where we can drill it back out and count the atoms one by one. We entered this cloud a few tens of thousands of years ago. We'll leave it in a few thousand more. The iron in that snow isn't a relic, it's a travel log, a record written in radioactive metal of exactly where we are right now. But picture the sun for a second, one dot, and the cloud it's sitting in, the whole thing we just spent this story inside, is itself a speck. Because the cloud is sitting inside something 1,000 times larger. It's called the local bubble, a near-empty cavern of hot, thin gas, roughly 1,000 light years across, scooped out of the dense material of the galaxy. And the sun sits almost dead center. How do you carve a hole that size? You detonate stars. Around 14 million years ago, somewhere near 15 of them went off here, one after another, and the force swept the surrounding gas outward, like air blown into a bubble. The gas piled into a dense shell on the outside and left a hollow in the middle. We live in the hollow. The iron in the snow is the residue of the very explosions that blew the bubble we're standing inside. And here's the detail that changed how astronomers picture our neighbourhood, from a 2022 study in Nature led by Catherine Zucker at Harvard. Take every young star, every active stellar nursery within about 500 light years of the Sun. For a long time they looked scattered, unrelated, but mapped in 3D, They all landed on a single surface, the shell of the local bubble. Every nearby nursery is riding the wall of this cavity, because the same shockwaves that hollowed out the centre compressed the gas at the edges, and compressed gas is what collapses into new stars. So the bubble isn't just a grave dug by dead stars, its wall is where the next ones are being born, and we're sitting in the cleared out middle of it. Now, back to that question from the start, whether any of this ever reached us. The deep sea record isn't flat, it has peaks, and the biggest lands around 2 to 3 million years ago. A peak that sharp points to a supernova that went off close enough that its debris didn't just drift past, it washed over the planet. Close enough to raise the question, did anything down here feel it? The cosmic ray flux? The climate? The atmosphere? I want to be careful because this is exactly where it's tempting to overclaim. We do not have proof that a supernova reshaped life on Earth. What we have is a radioactive timestamp showing one went off close enough to leave a mark in the sea floor, and a real unsettled argument about whether that mark goes any deeper than the mud. It's plausible, it's being studied, it's not settled. There's something here I keep turning over. We file supernovae under things that happen far away. Spectacular, violent, safely irrelevant to a Tuesday. Documentary footage. Someone else's catastrophe, 10,000 light years off. But that's not the relationship. The output of dead stars is here, in the snow, in the ice, more of it every year. The cavity we live in was carved by explosions. The nurseries hang on its walls. We're not watching the violence of the galaxy from a safe seat. We're standing in its fallout, drifting through its debris, built partly from the ash of stars that died before our species existed. In a few thousand years, we'll drift out of this cloud and into whatever comes next. Thinner, maybe, or denser, with its own history written in. The solar system keeps moving. The snow keeps recording. Somewhere in Antarctica right now, this year's layer is quietly logging exactly where in the galaxy we are, in atoms that won't finish decaying for millions of years. We didn't notice any of it. No wind, no sound, nothing in the sky. Just a slow, silent drift through the wreckage of ancient stars, and a thin dusting of radioactive iron on the poles, keeping the receipt. We'll come back to this as the deeper ice gets red. The record runs much further back than we've drilled. Until then, subscribe. This is First Signal.